All right, so have a little extra time that I didn't know that I was going to have because I guess we got evacuated today. So we do have our little final thing going on about conic sections. So I think I'll just take the time today to take a quick look at that. So here is our review. And before I start that, I thought it would be important to just kind of make sure that we all know the different forms that we're interested in. So right away, one thing to be aware of is in parabolas, that's the first one. We're looking for something that looks like either x minus h squared equals 4p y minus k. Now remember, if you have something like that, that means it's an x squared, so it's either going to open up or it's going to open down. And this is going to be if p is greater than 0 or p is less than 0. P is the distance from the vertex to the focus. This is the value p that we're looking at, or possibly this way, also p. When we graph them, we remember this was the focal width right here, and that value straight across all the way at the same level as the focus is 4p. Or if it opens side to side, it would be almost the same thing right here. Again, this is going to open either left if p is negative, or to the right if p is positive. Now that's the parabola. That's our setup. Now the ellipse, and actually the circle for that matter, kind of has this feel. So we go x minus h squared over a squared, y minus k squared over b squared equals 1. Again, if the value attached to a is larger, so in fact, the textbook always writes it this way, which is a little bit easier if I just take the time to do it this way. It looks like this because a is always larger. So if a is larger, it's going to open this way. And if right here, y minus k, and this is x minus h, and if this one, the y is larger, it's going to open this way. And again, the center is hk. And then this one, you would move this direction A over and back. And this one, you would move up and down A, up and down, okay? And interestingly enough, in these particular stories right here, the value that goes to the focal distance, the distance from here to the focus or from here to the focus, is a squared minus b squared. Again, it's the larger one minus the smaller of the two, and you square root it. Now, if it's a circle, what happens is A and B are the same, and if A and B are the same, that leads me to C being 0. The two foci are literally side by side. So I don't often talk much about the circle because it really is a special case of the ellipse. And then the final one is the hyperbola. And in this one, unlike here where addition is commutative, we can move it around. Right here in the hyperbola, it is not. So either we're going to have x minus h squared over a squared minus the y value, or we have y minus k squared. So in all problems, if we do not have it set up in this format, we're going to try to get it set up in this format. So if the x is first, it opens side to side. If y is first, it opens up and down. Okay, so with that context underneath our belt, when we look at this first problem, you can see the plus in the middle, which means it's going to be an ellipse. And we would like it to be set equal to 1, so we're going to go through here and divide everything by the number 48. Pretty simple little idea. Now, of course, when we divide through by 48, we get a fairly simple little setup like this. Clearly, it's opening in the x direction. It's going to be going kind of this way. Now, the problem only specifically asks for our vertices. So we need to start by finding our hk, which is our center. So I got -2 comma -3/4 sitting right here, and it's going to move in the x direction over and back 4. So the two vertices are going to be to the left 4, which is -6, and to the right 4, which is 2. And that literally finishes up all that we need to do on that one. Now, for this one, by looking at it, I can tell that only one square sits there, so that makes it a parabola. And based on the fact that it's a y squared, it's either going to open to the left or the right. And I'm not sure which one yet until I do some work. So the first thing that I think I would do is go ahead and factor it up a little bit. And everybody has their own style on this one, but this is the kind of the way that I think I would do it, is just group my y's together and my x's together. I'm going to go ahead and complete my square, which cut in half and square gives me 9. 4 times 9 is 36, so I had to balance it. Now, you might be a little bit curious why I have proceeded to leave this 4 sitting here, and it's just because I kind of had a feeling that it would just be a little bit easier if I left it alone. And so I've got a 39 to factor the 3 out, so it's looking pretty good. And so I just have one more little piece to do to get it into the right form. Now, I understand also that this isn't quite the form that we said we wanted, because this is supposed to be 4p. But in this problem, all I wanted my vertex. And so my vertex was at positive 13, comma, negative 3. There, we got it. Now, I'm going to jump over here and take care of this. Now, as it turns out, if 4p is equal to negative 3/4, then that makes p negative 3/16. Now, because this is a y squared that is negative, I know that the graph is opening to the left. So if I'm going to go to my vertex, 13, comma, negative 3, I'm going to proceed and move a little bit to my left, which is going to change this value and move to the left 3/16. So my focus is going to be 13 take away 3/16 would be 12 and 13/16, I guess, comma, negative 3. Now, that's looking pretty good. And now let's go ahead and look at this one. Now, what jumps out at me immediately is I've got both x and y are both squared, so it can't be a parabola. One is positive and one is negative, and that makes it a hyperbola. So we're going to go ahead and do a little bit of work on this. We're going to group our x's, we're going to group our y's. And I'm just going to kick this 12 to that other side. Now, again, in the completion of the square, we have to be really, really cautious here with that negative. So cut in half, 4 gives me 2. 2 squared is 4. So I'll be a little bit more careful with how I did that. That's equal to negative 12 when I moved it across. Now, this is going to actually give me a positive 12. And then over here, if I take 3, negative 3 cut in half, I get 3 halves. 3 halves squared is 9/4, which makes negative 9 halves. Now, this is why those things sometimes can get a little bit tricky, is because when I get to here, which is feeling pretty decent, I ended up with negative 9 halves. I'm just kind of peeking over because I've actually done an answer key before, make sure I didn't make some mistakes here. And so if I divide both sides by this negative 3 halves, this negative is going to become a positive. And so what I have is x minus 3 halves squared. I've got a y plus 9 squared. And of course, I'm going to divide everything by this negative 9 halves. And 9 halves divided by this is actually going to give me the number 9/4. Again, remember, dividing by a fraction is the same thing as multiplying by its reciprocal. So that's kind of the reason some of these things are happening. Here, if I divide 9 halves, I would get 9/6. 9/6. You could also see that I could divide the 3 across. You know, that would give you, but 9/6 divided by 3 is 3/6, or I guess 1/2. Nope, it's got to be 3 halves. Oh yeah, 9 halves divided by 3 is 3 halves. There we go. Now, as far as finding the vertex of that problem, we're going to start at our center, which is 3 halves comma negative 2. I know that it's opening in the x direction because x is first. And so I'm going to move over and back 3 halves. So from 3 halves, if I move to the left, I'd get to 0. And if I move to the right 3 halves, I would get to the number 3. Now, again, trying just to stick with the theme here, since I have it, let's go ahead and find the focus in this particular one. So again, because we already have it in the nice, pretty form, I'm going to start at the center, 3 halves comma negative 2. That's HK. And in the right and the left, I'm going to move over and back what we call C. So I need to take 9/4 plus 3 halves. Now, 9/4 plus 3 halves, I'm just grabbing a calculator real quick, is 15/4. So I need to go to this value, 3/2, comma -2, and I move to the right and the left the square root of 15/4, which of course, if I wanted to, I could call that 3 plus or minus root 15/2. And that kind of finishes up how you find the foci. Now, the last one of these that I don't know why I changed this problem. I probably should have just left this as problem number 1, but I didn't. I was trying to, demonstrate a few things. But when you go ahead and try to find the foci of an ellipse, what we need to do is we need to take the large one, 4/9, minus the small one, which I'm going to call 3/9. So C would be the square root of 4/9 minus 3/9, which is 1/9, and the square root of 1/9 is the third. So if we go to the center, which is -4/5, comma 2/3, I need to then move up and down exactly 1/3 to get to my foci. So the two foci are -4/5, comma 1, because I went up 1/3, and -4/5, comma 1/3, because I went down 1/3. And so that video specifically just talked about finding vertices and foci of the ellipse, the parabola, and the hyperbola. And that will do it for video number 1. In video number 2, we'll look at the next series of problems. All right, see you soon.